Hi, my name is John Wiedemeier. I'm Product Marketing Manager for Teledyne LeCroy. And I'm going to talk to you a little bit about protocol testing. And one of the things I think many of you know about is, you heard the word protocol, and what does a protocol do? Basically, it governs the I/O in many sophisticated systems. Protocols are becoming extremely sophisticated, doing a lot of different types of control. I'm showing here some basically protocol stacks of some of the new common protocols that are out there. And I'm going to try and kind of go between two extremes here. I'm going to go between the SSD and IOT type of applications. And one of the things I think about protocols is that, if you think about the things you have in your home and your workplace, you're very interested in being able to have small devices. You're interested in having connectivity to the internet, and you want to be able to have all kinds of power-saving modes for applications that are on your person, so that you can have a long battery life and use your applications as much as you need to. And all of this is the responsibility of the protocol and the interface that's part of that. And so, as you can see here from these diagrams, we have some SSDs and we have some other personal appliances that are there. Also, these protocols govern performance and also this data reliability. And these can be tuned per application. So some applications don't need all this stuff, and so you can kind of remove some of that from your application. But the power and ability are there. And then also, with these new protocols, we have a lot of people who are moving from different technologies, and they want ease of use. They want to be able to take a protocol and immediately be able to port pre-existing applications to it, and so they want that compatibility there. So there's lots of things that are put into this. So one of the technologies that I have been working on with for many years here is the PCI Express. PCI Express was one of the main interconnects that are out there in the industry, embedded board industry as well. And recently, in the last few years, we've seen PCI Express move into the storage realm. And as we talked earlier in this meeting, SSDs have become prominent with PCI Express interfaces. There's two platforms that we've been seeing a lot of, and that's the kind of the standard SSD with an 8639 connector on it. We've also seen this thing called an M.2, which is basically like a size of a stick of gum and being used in a lot of the commercial products that are out there. All of these have PCI Express interfaces, and once again, pushing envelopes of over terabyte of storage on them. So very, very small, very low power. All of these considerations are part of the protocol that's on them. So one of the questions people have is, so I've got the PCI Express devices. Whoops, here we go. I've got PCI Express devices, so how do I test? Most of the industry for the last decade has been using, SAS, SATA, fiber channel type of protocols. And the thinking was, well, when I move to something new, I'll just take the same testing implementations with me. Well, PCI Express is extremely fast, and there's some different considerations around it. And in this process, test methodologies have had to change. And so the question is, what is the best way to test a PCI Express-based storage? Well, there's actually two that have been formulated in the last couple of years. One we've had for many years with PCI Express, and the other is more of a conformance. So we've had a kind of compliance and conformance. Seems like the same word, but a little bit different. And I'll get into that a little bit here. The first one here is compliance. Compliance is done by the PCI SIG standards group, and basically they govern all the electrical considerations and all of the software protocol piece of PCI Express. And what they're trying to do basically is find out how well these devices work with the interface side and how they work in a system. And the idea is that we want to make sure that when a system goes down, that data is preserved. We don't ever want to lose data. Whenever you get that blue screen, that's a scary thing because it means you're losing data. And so what we want to be able to do is, with the protocol, have a graceful way of shutting down a system when an error occurs. And so that's what the whole idea is with the PCI SIG and their compliance test, is to do this. I have here a picture of the Teledyne LeCroy's Summit system. And what this is an analyzer, an exerciser, and test platform. And this is the predominant way of doing testing for PCI Express. Basically, you can see that an SSD is plugged in on top, and then we have an exerciser card that runs a set of tests that have been sanctioned by the PCI SIG as the way to test. And so this system here is quite robust and very powerful, even to add additional testing by companies' own test methodologies. The second way to test PCI Express storage devices is through the Interoperability Labs in New Hampshire. They have, for the last decade, been doing much of the compliance standards for SAS, SATA, Fiber Channel, and Ethernet, and now PCI Express. And they're also using the same setup we have for their interoperability test. And very, very powerful. Once again, I said a lot of flexibility there. But what we do here at these events, and I go to these 5 times a year for the PCI SIG, and then I do a couple of these for the UNH, is companies from all over the world who produce SSDs or storage systems come together and they run a battery of tests. And then they try and plug into each other to make sure that they interoperate. And you'd think that that would be a simple thing to do. If you design to a spec, it should work like that. And most of the time it comes close or meets the goal. But there are always some little, sometimes inconsistencies that are discovered. And this is a great way to increase your quality by going to events like this to get that hands-on experience with your tests, with your setup. In addition to these test methodologies, we've seen a need that with the storage industry, they need deeper buffers. And in other words, a lot of companies want to be able to sit and just record a stream of data coming in from their systems and just analyze if there's any anomalies that occur over time. And so we have taken a new class of analyzers and increased the memory size to be able to do that analysis. In addition, we've added additional ways to probe these devices. So as I mentioned before, there's an M.2 form factor, there's this 8639 connector, 8640, 8680s. There's all kinds of different connectors that are coming out in the next while. And my job as a product marketing manager is also to pay attention and try and predict the market, figure out what's going to be out there, and provide these solutions ahead of time for for early developers. So as you can see here, you have a very powerful system with a variety of ways to interact with storage systems. Now, moving into something interesting here, the Internet of Things was discussed earlier, and I was surprised that the name of the term was used so early in time. But I was taking a poll last year about what does the Internet of Things mean, and I couldn't find a consistent definition of what that meant. And even my company, I was struggling with trying to figure out what it was. And then I was at a sales conference, and I just threw out the question, what does this mean to you? And one person came up and he says, you know, it's Skynet. Anybody remember Skynet? That was from the movie Terminator. And basically the machines took over the world and it didn't end well for mankind, at least the last episode. So, you know, but you know, I think what we're doing here is we're building a friendlier, kinder Skynet. And if you look at you know, what we're trying to do here, we have server systems in the cloud, right? And you know, so there's some need for technology there. And then we have, of course, all of these devices that are out there. And we've had, of course, you know, tablets and laptops and other systems, cell phones and things like that have been attached for a while and providing us all kinds of applications. But now we're hearing about, you know, the Google car and all of the automated automotive vehicles that will be coming. And we've seen things like trucks and equipment being monitored through through applications, so you can be able to see where all your heavy-duty equipment is placed around the country, or in your lab, or in your facility, and keep track of things like that. So a great way to track things. We're hearing about farms that are potentially going to be using unmanned equipment to plow fields and harvest various crops, and and it goes on here to the point where we even see cities looking to use the Internet of Things to keep track of traffic control systems and water and disposal of hazardous waste and things like that. All this controlled by the Internet of Things. And of course, the next step, and I guess you could argue and say it's already here with the U.S. and other countries, is that the country itself, through think of all of the different technologies and companies and infrastructures with air travel and shipping and all that, it's kind of already here. We're kind of already being controlled a lot. Our lives are certainly affected by that. But anyway, all this technology needs protocols. Thank goodness for my business. There's some heavy-duty things that are happening, and people are really interested to know that we continue to watch and provide new ways of exploring and being able to decode and develop ways to help enhance the development of these kinds of products. So on the cloud side, obviously the servers, there's a wide range of form factors, as many of you have been just mentioning in your presentations today. And we have tried over the many years to try and keep up with all of the different form factors that Vita and PicMig and all those put out. And we continue to work closely with actually many of you in this room with your next generation designs. And once again, I encourage you to seek me out if you've got some projects or worry about connectors and probing and things like that. I'm always open to hear what you have to say. I'm trying to always build the next year's portfolio of new types of interposers and probing. But you can see here we have rack mount support, AMC, VPX, compact PCI serial, XMC, and we have also flying lead type of probe technology where you don't need to use an interposer, but kind of be able to connect directly into the circuits. We have all that available for development today. The way these interposers are used, they're all very, although they're different, but the similar way is you're taking the interposer, and as opposed to having to drill a hole in a board and connect a wire and try and set up some kind of a probing adherence. With an interposer, you simply plug it into the backplane, put your device into it, and you're ready to go for a measurement. Really easy, quick to do, and all of our analyzers work with all of our probes, so it's very simple. You just pick what you need to make it work. And these interposers provide a way of tapping, and then I'm showing here a diagram of one of the many analysis views that someone's using, for example, low power mode, right? So this particular thing is going into kind of a sleep mode, and you can see that we can monitor all the states as it's going in and out of sleep modes, and this is sometimes an issue if firmware isn't set up properly. We can see things bouncing between states and having to restart and cause performance issues. But there's many different views to find various issues, and that's what the protocol analyzer does. So we just talked about the cloud side. Now I want to talk a little bit about the kind of more of the consumer side, personal aware kind of technologies. And there's this new technology called MFI. This is through the MIPI organization. Many have heard of that. They've done DeFi and MFI technology. And so MFI is the new higher speed technology and lower power. And what I'm showing here is a kind of a protocol diagram showing you all the different protocols that exist on a MIPI MFI layer there. And these different protocols service things like the ability to take a picture, camera, manage memory, run your displays. So any kind of small objects, watches, all this personal material you're going to see on that. Anyway, there's a wide range of these, and some of them have overlap, but they all run on the MFI. And we have recently developed some tools that help with that. So as I mentioned, some of these things that are out there, obviously that the Google Glasses is still moving along here, but everyone's trying to find all these personal ways of monitoring our health, medical devices to monitor our health as well, wristwatches, entertainment, ways of communicating, and all of these small devices may have several protocols running on them. And so the idea is that, is there some way we can consolidate these protocols, make it more efficient? Can we consolidate buses so that we don't have a variety of buses with different power considerations and try and get them all down to one or two of these things, and then we can make it more efficient to basically get time to market, right? In other words, instead of taking a year to worry about all these, you have one protocol, one bus ideally. It's faster to create these things and move forward. And so, but one of the issues here is that these devices are very tiny and small. And so how do you debug this stuff? What kind of equipment would you use? How do you attach to this stuff? And so this has been a real challenge for the MIPI Alliance. And so we have produced another analyzer aimed at all of those protocols that I showed you in the previous diagram. So being able to do MPCIe, being able to do UFS and DFS and CSI and all these, this analyzer is going to be capable of doing all of those things. And as a result, we've had to create new ways of attaching to these MFI devices. And so one of the ones we have here is an SMA interposer. We have like a ton of these SMAs on there, and we're able to connect into most applications that are most likely by one or by two, very small, high speed, low power, and this analyzer is capable of being able to show the protocol in great detail about how that protocol works. So we have 4 different methodologies there: the mid-bus, the M.2, they also use the M.2, and the multi-lead or flying lead attachment. So in summary, I want to point out there's new protocols. The Internet of Things is becoming very important to all of us, and there's new ways that are being developed to test these new types of technologies and protocols. And we've created new test equipment and new probing technologies to help everyone with their development and interoperability testing. So thank you.